to my YouTube channel. My name is Steve, and I want to show you some simple stuff here to help you get started with the assembly language, and hopefully you'll be able to pick up on this. Okay, so first of all, I wrote a little document here. I'm going to kind of read through it and kind of explain step by step some of the things that's going on here. So first of all, what is the advantage of learning assembly language versus BASIC? Okay, so I found two great examples while I was searching on Google that highlight this point. You think of BASIC as a bicycle that can reach a maximum speed of about 10 miles per hour. Think of like a 10 speed, up to about 15 miles per hour. So BASIC can be like chugging along to get you to a destination, but it kind of takes time to get there. And let me zoom in on this too for those mobile people. That would be if I can get my zoom to work. And there it goes. Okay, so there we go. Let's see, something like that would be good, I think. So I got a little example of a bicycle to kind of show you. I'm going to get used to how the zoom works. Okay, so there we go. Now imagine if you want to get your programs moving at lightning speed. Well, I figured using a Porsche is a good example since it is pretty fast for a road vehicle. With this car, assembly language, you can reach speeds up to 160 miles per hour and even faster. This is because your computer is communicating directly at its level down to the binary messages being delivered. And there's an example of a Porsche. So you can think, if you want to go from BASIC to assembly language, there's a great example. You've got a great head start of everybody. I mean, think of a Porsche trying to race a bicycle. I know it probably seems like a silly example, but it really is a good comparison because machine language and assembly language does loops around BASIC. What is a memory address? I wanted to kind of touch on this. And I did mention this before, but I wanted to decide to show you a different illustrated example that will hopefully, shed some light on this for you. And light is going to be the keyword later. Okay, think of a memory address as a home address. Inside your computer, you can visit from 0 to 535 different houses, or what are known as addresses, using a poke statement. And I drew a picture here to show you, and this is taken from the example in a book. So address 1 would be like house 1, address 1, address 0 would be house 0, house 1, house 2, house 3, house 4, house 5, house 6, all the way up to 535. Hopefully that, conveys what I'm trying to point out here. So just imagine those poke statements representing those houses. Each house contains lights, and this is where I'm going to get to the next example I was talking about. Sometimes the owner has the lights off, and sometimes they are lit. These lights are activated whenever you use a poke statement and enter something. As an example, if you poke 646,2, which is the color register, by entering that 2, you just turned on that light in your computer's memory. So right here, this 2 represents the light. Now also imagine that each house can light from 0 to 255 different lights. These are the lights, or known as bytes, that can be activated using the poke statement. Okay, let's finally activate some of those lights using the assembly language. I will show you the BASIC example, then I will show you the assembly language one. Okay, so BASIC, you saw this example earlier. Poke 646,7, which basically is the foreground color register, and it's going to put a 7 in there, which is actually the yellow color. It's going to turn the screen yellow, basically. And then next is the assembly language example. Remember the 646, you're taking the 7 and you use an LDA, or load the accumulator, with the immediate value of 7. This is how you access that light, or that byte in your computer's memory. And then you store it into the memory address, or the house, as we mentioned. And this is house 646, which I'll explain down here. This RTS will return you back to BASIC. So make it a habit to use an RTS in your assembly language when you want to return to BASIC again, as I just mentioned. Now let's learn how BASIC reads assembly language into its memory. First, you would need to read the data into memory with a for next loop and a data statement. And I have provided an example here. Look at the example. type it in your computer. It's pretty simple. This will help you learn it. This translates as count from 0 to 4, you got it right here, 0 to 4, and read from the data line. So basically this read right here is reading this data statement into memory, and this is where it's going to store it in this variable here, into the by variable, or you can call this variable whatever you want. Just make sure it's 2 letters. I could call this AA, or, well, you wouldn't use lowercase, AA, BB, or whatever you want to call it, basically. It's simple. There's no limitation to what you can do with it. You can just use any kind of variable names. I just lost my place there. I'll type down here real quick. Okay, the next thing you're going to do is you're going to poke into memory, or you're going to activate house 49152. And in your computer's memory, 49152 is not being used by BASIC, so it's safe to use this memory up to, I think it's 53247 if I'm not correct. So, to show you, 49152 up to 53247. Anything beyond that goes into the sprites. And this translates as count from 0 to 4, and kind of what I said, read the data line into memory, store it in the by variable, then enter instructions using the poke statement, and find the safe place, which would be at location 49152. Then add the contents of that loop to get the next data statement. The next means continue until we are done. So the next here goes back to this for loop once it counts through. So the first time it's going to say 0, x is equal to 0, go all the way through the loop. Then x is going to be equal to 1, go all the way through, it's going to be 2, go all the way through, it's going to be 3, go all the way through, it's going to be 4. So that's basically how that works. And here is the assembly for those who want to see how the bytes match up to the instructions that I listed above. Read the byte, or the byte, which is number 7. Store it into the foreground color, which is house number 646, or memory location 646, and return back to BASIC. And if you want to see the math behind it, let me show you this too. I forgot to add these bytes side by side here. Let me do that real quick. I was going to skip a step here, but I wanted to put these right beside here so you can kind of see what each one is doing. This would be the store, and then this is 169,7 for those who want to know, and this one is 96. So kind of like that. Hopefully you can see it's kind of messy, you know, kind of shifted everything to the next line, but the thing to concentrate on is right here. If I can highlight it, load the accumulator, store the accumulator, and then your RTS. And these represent right here. 169 represents load the accumulator, which is the command instruction to use LDA. The store instruction is used by instruction 141, and then you've got the 96, which is the RTS. So we are reading from the accumulator the value of 7 and storing it into memory location 646 and returning to BASIC. And I did mention house 646 as an example has now turned on light 7. So that's what I wanted to show you. It's kind of a simple example. And for those who want to see what I was talking about here, this is actually an opcode guide. If you look on here, you'll see, I'll zoom in there, I'll show you 141. See, 141 is store, and then 169, which I think is down here somewhere, is right there, LDA. And then you got the 96, which I think is up here somewhere. Right there, RTS is 96. So it's basically where you're going to get them. And having this kind of guide is good for assembly language. I just kind of look them up on here whenever I want to figure out what instruction to use for what. So this is a simple example. I didn't want to stretch it too far. I want to kind of break this into a small series to kind of guide you along the process, and hopefully this will get you started playing with those house addresses. Get the memory mapping book. I showed that before, I'll show it again, but make sure you get this book or find a PDF online. Very good guide to looking up those memory addresses and knowing what to do with them. It's going to take some time to really learn it. There's 65, 535. Many of them are sectionalized. Like you got page 0, page 1, page 2, page 3, page 6. And they're broken down that way to symbolize what each would do. Like page 0 which is from 0 to 255, does a lot of the regular in-house processing kind of things for your computer. And then you got, I think, page 1, if I'm not mistaken, is where you can actually take advantage of some of the information found there. And of course, all the way up to the larger pages where you got the sprites, data, I/O processing, and all that stuff going on. So I hope you guys enjoyed this video. I'm going to cut it short because hopefully I haven't killed my audio by now. So please subscribe if you like this, and thanks for watching.